In this video lecture, we will discuss about carbenes and we will discuss about structure of carbenes and different types of carbenes. So let us begin with carbenes. Now these carbenes, they are reaction intermediates. They are highly reactive reaction intermediates in which carbon has 6 valence electrons. So carbon has 6 valence electrons. It is divalent in nature. That means carbon forms a 2 covalent bonds with 6 valence electrons. It is neutral with 0 any formal charge. So what are carbenes? These are highly reactive reaction intermediates which are neutral in nature, divalent, that means carbon consists of 2 covalent bonds, and carbon has total 6 valence electrons. So we can write the structure as, so if this is carbon, now it is divalent in nature, so it has 2 covalent bond like this. So here may be it may be R or it may be R prime. So 2 valence electrons are involved in this covalent bond, 2 are in this covalent bond, so there are total 4 electrons, and the remaining 2 electrons, they are present as such. The remaining 2 electrons, they are present as such. So you can see here there are total 6 valence electrons. Carbon is divalent and there is no formal charge over this molecule. So this is a neutral molecule. So since there is total 6 valence electrons are there, so which involves 4 bond pair of electrons, 2 non-bonding electrons which are localized or the present over carbon. So this leaves 1 orbital vacant. So there is a 1 empty orbital which is present over this carbon. Now since these carbenes, they consist of only 6 valence electrons, so they are electron deficient in nature. So they are electron deficient in nature, and therefore they act as electrophiles. So they have a very strong tendency to accept electrons, so they act as a electrophiles. To complete octet of electrons, they can accept 2 electrons. So there is a 1 empty orbital present over this carbon. Now these carbenes, they can be classified first of all, so we can draw a structure in more detail as, so you have a carbon with this one. Now this is a methylene carbene. Since there are 2 hydrogens there, similarly you can have a dichloromethylene carbene in which you have a Cl, this one. So this is dichloromethylene carbene, which acts as an important reaction intermediate in many reactions. Now we can divide these carbenes into 2 categories depending upon this pair of electrons. Since there are 2 pair of electrons which are present over this carbon, now there are 2 possibilities. These 2 electrons, they may be present with anti-parallel spin or they may be present with parallel spin. So depending upon spin of these 2 electrons which are present over carbon, we can classify these carbenes into 2 categories. So the very first type of carbene is a singlet carbene, and the second type of carbene is a triplet carbene. Now here singlet and triplet word, they define multiplicity of particular carbene. Now, and as we know, the multiplicity can be calculated by formula 2s plus 1, where s is a total spin. Now since there are 2 electrons which are non-bonding electrons present over in this carbene, so these 2 electrons, they may have a anti-parallel spin or they may have a parallel spin. Now the spin quantum number of each electron is 1 by 2. So this s is a total spin of the system. Now if both of these electrons they have an anti-parallel spin, in that case they will cancel out each other, so the total spin will become 0. And if you put 0 in this formula, the multiplicity will become 1. So the carbenes in which both electrons they are having opposite spin, they will have a they have a 1 multiplicity and they will be called singlet carbene. On the other hand, if these both electrons they are having parallel spin, in that case the total multiplicity will become, the total spin quantum number will become 1. So the multiplicity will become 3. So that carbene will be called triplet carbene. So in case of singlet carbene, both electrons they are having anti-parallel spin, they cancel out each other, so this multiplicity is 1. While in case of triplet carbene, both electrons they are having parallel spin, so their multiplicity is 3. So that's why they are called triplet carbene. So let us look at the structure of each kind of carbene separately. So let us begin with the singlet carbene. So as I already told you, in singlet carbene, both electrons which are present in carbon, they are having anti-parallel spin. So here in this case, suppose this is your carbon. In carbenes it is divalent in nature, so these are two covalent bonds. So this is R, say this is R prime. Now in case of singlet carbene, this carbon has sp2 hybridization. So there are 3 sp2 hybrid orbitals. 2 are involved in formation of these single covalent bond, while third sp2 hybrid orbital, it consists of non-bonding pair of electrons, and both pair of electrons, both of these electrons they are present in same orbital, and since they are present in same orbital, they must have anti-parallel spin. So here in this case, this carbon has a trigonal planar structure, and this non-bonding pair of electrons, it is present in sp2 hybrid orbital. So this leaves one unhybridized p atomic orbital perpendicular to the plane of these hybrid orbitals. So this is unhybridized p atomic orbital which is vacant. So this is structure of singlet carbene. So in case of singlet carbene, your carbon, it has sp2 hybridized, both electrons they are present in sp2 hybrid orbital, and there is a one unhybridized p atomic orbital which is vacant perpendicular to the plane of these hybrid orbitals. So it has a trigonal planar structure. So they have a trigonal planar structure. Now in case of triplet carbene, the multiplicity of triplet carbene is 3. So this means both electrons they must have parallel spin, and both electrons they will have a parallel spin only when they are present in different orbitals of the same energy. If they are present in same orbital, then according to Hund's rule they must have opposite spin. So if they have to acquire a parallel spin, they must be present in same they must be present in different orbitals of the same energy. So here in this case, these triplet carbenes they have sp hybridization. Now since they are divalent in nature, so there are two sp hybrid orbitals that are involved in formation of covalent bond. So here they are involved in formation of covalent bond. This leaves two unhybridized p atomic orbitals. So there are two unhybridized p atomic orbitals. So suppose this is p, suppose this is py and pz. And since both of these unhybridized p atomic orbitals they are having same energy, so each unhybridized p atomic orbital acquires one electron. So here in this case, in case of triplet carbenes, they are having planar geometry with sp hybridization, and both non-bonding electrons they are present in unhybridized p atomic orbitals. Now next is, let us look out of this triplet carbene and singlet carbene, which is more stable. So we have already discussed the structure in singlet carbene. Carbon has sp2 hybridization, bond pair of electron present in sp2 hybrid orbital, and two electrons they are present in same orbital, and this unhybridized p orbital is vacant. So this is singlet carbene. Now in case of triplet carbene, they are having linear planar structure with two unhybridized p atomic orbitals present perpendicular to these sp2 hybrid orbitals and containing one electron in each orbital. Now here in this case, in singlet carbene, since both electrons they are present in same orbital, so here in this case there is a more electron-electron repulsion. In case of singlet carbene, since both electrons they are present in same orbital, so there is a more electron-electron repulsion. While in case of triplet carbene, since both electrons they are present in different orbitals, so here there is a less electron-electron repulsion since they are present away from each other. Both electrons they are present away from each other, so there is a less electron-electron repulsion. So since electron-electron repulsion in singlet carbene is more as compared to triplet carbene, so these triplet carbenes they are more stable as compared to singlet carbene because of lesser electron-electron repulsion, as both electrons they are present in different orbitals. So this was the structure and the types of carbenes. So in this lecture we have discussed what are carbenes. So what are carbenes? These are reaction intermediates in which carbon is neutral, it is divalent, that means it forms a two covalent bonds containing 6 valence electrons, and there is a one non-bonding pair of electrons. And depending upon non-bonding pair of electrons, whether both electrons they are paired or non-paired, they can be classified as singlet carbene in which both electrons are paired. So singlet carbenes they are having sp2 hybridization, trigonal planar geometry. While in case of triplet carbenes, both electrons they are having parallel spin unpaired, so they are having sp hybridization in which both electrons they are present in different orbitals, and they are having linear geometry, or the linear geometry, not planar. Here it should be linear, so they have a linear geometry with sp hybridization. Now since out of the singlet and triplet carbenes are more stable, as there is a lesser electron-electron repulsions, as both electrons they are present in different orbitals.